Hi everyone. So this is the Sarafu Network demo. So we have a configuration ready with 36 migrated users. So we're just going to demo transactions on the Sarafu Network. So what we have is a USSD interacting with our blockchain. So in this demo, what we can see is Phil's phone. This is with the gray background, and my phone with the which is on the right with the red logo in the center. So what Phil is going to do, he's going to send me some Sarafu right now, and we're just going to observe the entire transaction process. So Phil, back to you.
Okay, sending now.
So this is the Sarafu shortcode that Phil just entered, and this is the USSD code running. We can see he has around 17 Sarafu. So he's going to send it to me. So we can see that there was a confirmation that Phil has sent me. So we're just going to wait. So as this is happening, the transaction is being mined on the blockchain, and we have received some Sarafu from Phil on my phone also. So if we open, we can see the message here that Phil has sent me. So now the next step is actually to see what is happening in the background. So the first step we're going to do is we have a couple of internal tools that we use to monitor the blockchain. Aside from that, any independent person can verify these transactions with Web3. We're also going to demo that. So for starters, we're just going to see with our first tool, which is called CIC monitor. So this is just a generic blockchain monitor. It will go through all the blocks, and it will with predefined filters. So in our case, we are trying to filter for ERC20 transactions. This code is also open source. You can find it in our Git organization. So yes, so first thing is that to identify where this must have happened approximately. So with that, we also have our miner here. So this is our blockchain miner. It is running on Open Ethereum, and we can directly see the debug logs. So we can see that there was a transaction mined on block 712, 713. So this is probably what we're looking for. So with CIC if monitor, we can just go and define that. So this is the command for running it. So the GE render is going to load our filters. This is our RPC endpoint. This basically connects to our blockchain. It is public, anyone can access it. So yes, so we're going to start with around 1700, and we're going to let the monitor do its job. So we're just going to wait as it goes through the transactions. So yes, we quickly found it that on block 713, this Sarafu, this is in units, was sent from this address to this address. So now we have another tool, like how do we identify who owns this address and who owns this address. So for that, we have an internal tool used by most of the staff. So again, before proceeding to that, I just wanted to also show this is a USSD emulator that we wrote also. So this is just like using a phone, but it runs on the client. So you can see that my balance right now is 76 Sarafu. So now going back to the other tool. So yeah, this is our internal tool called Clickada. So what Clickada does is that it will query the blockchain, and it'll also query our metadata just to combine those results and see like who has sent that. So this is my number. So these are just a lot of like connection parameters that we use, like okay, connect to our server here, connect to our auth server here, connect, this is our registry address. So this is a bit a high level, but I'm just going to run this. So this is my phone number that Phil sent to. We can see that the blockchain address here is this 747B7. If we go back here, we'll also verify that it was from 47B7 to 247B7. So we can see that Philip, in our latest transaction, Philip sent me 5. So yeah, so now we can also see on Philip's side this transaction. So we can just copy his number and see. Oops. I must have copied. So you can see this is this phone number is registered to Philip Wanga, and his custodial address is this, and he sent me this. And we can also see his past transactions that he had previously sent me 12 and 25. So now this is just with our tools, like how do we verify that this actually took place on the blockchain. So with that, we're going to do like a pure like other tools. So we're going to use Web3 for this, just purely Web3. So for this, I've written a Web3 REPL. So this is again open source on my Git, but you can use any Web3 library. This just calls the Web3 functions. So what we're doing here is that we're connecting to a blockchain, and yeah, we have the our Web3 interface ready. So we're just going to do. So notice that we had the transaction hash here, so we can just use this. That was mined on the blockchain, so we can just copy this. I've copied it, E3C, and you're just going to use a Web3. So Web3 if.get transaction. Since this is a promisified method, we're just going to wait on it, and we get some data. So now how do we decode this data? So for that, there are a couple of tools out there in the public. So I just quickly googled an ABI decoder and found this one here, where you give it an ABI, give it the input data, and it's going to decode everything. So our smart contracts are open source. So for the token that is currently deployed, it is a demurrage token of type single no cap. So this is the ABI, the JSON. So I'm just going to copy this, and I'm just going to put it here, and the input data, we're just going to copy it from the blockchain. This is the input data, copy it, so and you're going to decode it. So we can see that this is the input to 7B7, that is my address, and this is the value. So this is a hex value, so we're going to go and further decode this. So we can just decode this on the command line. So just going to go ahead and decode that, and yeah, you can see this is the exact value that was displayed in our internal tool, which was here. So another thing is that our system has something called CIC cache, which could be which is the equivalent of the graph. So I think most people have heard of the graph. So this is like a public blockchain indexing that works through GraphQL. So we have something similar, very similar in fact, and it's called CIC cache. And what it does is basically just caches all the results block by block, so that we can know, because as the blockchain runs and grows in size, we can easily look that value up. So this will also have cached our data. So we're just going to look for it. So it will be the last transaction. So this is the transaction. So this happened 44:26 GMT time, and we can see this is the value in units, Sarafu units, and this is the destination token address. So this is the token address, and we can see the sender. So the sender here is Phil with 483, and the receiver is me with 7B7. So we can go ahead, go back to our meta and verify. Phil's network address is 483 and my network address is 7B7. So yeah, we also have so this is just the CLI, so sometimes it's not really very user friendly, though for developers it's probably the most user friendly. So we have a blockchain explorer in the works which will simplify all this. So we're not going to use like Etherscan. It's going to be something very similar to Etherscan, so we already have that in the works. We can see it here, Kitabu blockchain, Kitabu chain explorer. There's a couple of pages already done, and we will have this set up soon, hopefully in a few months, and then we'll be able to see these transactions on a very nice GUI. So I think, yeah, this is the Sarafu demo. Will, do you have anything to say or feel?
No, thanks, Sohail. That was awesome.
Alright, so I'll just end this recording.